everyone! Alright, in the last video we got the motor spinning. Let's have a look if we can understand what the code is doing. This line of code here includes this library. A library is code that someone else has written and packaged up that you can use, and this is the Adafruit motor library. Good. This one makes a new variable called motor, and the variable is of type DC motor, Adafruit DC motor. A variable in programming is something that stores a value. For example, name might be a variable, or age might be a variable. If you think about the type of these things, age would be, what type of thing would age be? So examples of values might be 10 or 15 would be a value for age, and the type for age would be integer, a number. Whereas name, name might be Ranieri or Bob, that would be text or a string. This variable stores a variable of type motor, specifically Adafruit DC motor. The fact that I've imported the library means that I can declare variables that are a motor type. When I declare the variable, I can also specify the pin that it's on, the motor number that it's on, and in this case I wanted motor number 4. In any Arduino program, the setup function runs exactly once at the start of the program when you first boot it up. For example, if I unplug it and plug it back in, the setup program will run once. Or if I press this reset button, the setup program will run once at the start. So these lines of code will run once. It will first set up the serial port so that I can send data. I'll just pull this out. So that I can send data through this serial chip here to the computer and receive data from the computer. It sets it up at this bit rate, 9600. It will send this message through the serial port to the computer, and to see that message you click on the serial monitor. That's very useful for debugging, figuring out whether your program is working or not. It will set the motor speed to be 200. We might even, let's have a look. Let's go in Adafruit motor shield library. So these functions here, they are documented. So on the internet, you can find a reference on what these things are. For example, using DC motors, we can learn about how they're all connected, the different ways to use set speed, and so on. And here I notice that set speed ranges from a speed of 0, which is stopped, to 255, which is full speed. After it's done that, it will release the motor. So it actually turns it off initially. I'll pop this back on just so you can see what's happening. So if this setup code was all that was happening, then all that it would do is set the speed to be 200, but then disable the motor. Let's check. If I get rid of everything inside loop, I'm going to get rid of all of this stuff inside loop, so that there is nothing inside this loop function. Every Arduino program has a setup function that runs once and a loop function that runs over and over again. This program, now that it's a bit simpler, will only set up the serial port, send a message, set the motor speed to 200, and then turn off the motor. Let's upload this program and check that it does nothing. Check that it prints the message but does not move the motor. It says done uploading. I've still got lots of messages here from last time I ran the program. So I will clear these messages. And if I restart it, this button here is a reset button. Good. So it prints motor test, sets the speed 200, and turns the motor off. Let's go back to this page here. What else can I do with motor.run? I need to give it a direction, and the direction is either forward, backward, or release to turn it off. So let's try now changing this to be forward. If I run this, hopefully the motor spins forwards. Forever. One eternity later. I have just noticed a problem. I've noticed why it hasn't worked. This one was not aligned. I'll fix that up and make sure that I align those pins to actually go in the hole where they're meant to. One of them was just loose. There we go. So now, set motor speed to 255, motor.run forward. There, oh, there we go, very, very good. So it's running forwards on its maximum speed. Suppose that I wanted to make it go backwards. Well, the instructions, not that one, say that I could do forward, backward, or release. So I could make it go forward and then delay for 1 second. When I write delay, that will pause the program, and it says that it takes a number in milliseconds. So 1,000 milliseconds would be 1 second. So I'll make it go forwards at max speed, wait 1 second. I will get rid of this comment here. A comment is code that helps you understand what it's doing, but doesn't mean anything to the computer or the microcontroller. So I'll get rid of this just so there's less for us to look at. And I'll copy these 2 lines down here to make it go forward at full speed for 1 second, and then set it to be going backwards, and then wait 1 second on backwards. Remember, this will only happen once. I might at the very end, after this has finished, stop the motor. Motor.run, if I have a look at the documentation, motor.run, I can add release here as a parameter. So if I run this now, it will set the speed to forward, full speed, wait, do that for 1 second, set it to backwards, do that for 1 second, and then stop it. And sure enough, that seems to be what happened. To make it easier to see what's happening, that's where serial.println is really helpful. I can say forwards, forwards, and then I can copy that line and here say backwards, just before I start going backwards. And then right at the end, I can say finished. That will make it a lot easier to figure out what is going right or wrong in the program, to understand what is happening in the program, because I can check in the serial monitor that first it prints forwards, goes forwards for a second, backwards for a second, and then stops. Good. In the next video, I will show you how to do loops so that it runs forever, and I will show you how to add, well, I'll give you a hint on how to add an extra motor. All right, bye everyone.